Hello, I am Kanna, welcoming you all for this NIA SDC storage conference. And my today topic presentation is managing cloud infrastructure by using Terraform HCL, HashiCorp Configuration Language. Before going to see our presentation, I like to say a few words about MSys Technologies. We are product engineering services and digital transformation partner. We are working with top storage companies like Rubrik, Pure Storage, Perversity, and also working with global enterprises like Amazon, Google, Bug. And we got a lot of awards. And also we are one of the top fastest growing storage companies for 2 consecutive years. Okay, let's go to our session. And the agenda for the today's session is cloud computing. We are going to see about basics of cloud computing and the advantages. And we are going to see about cloud infrastructure, various cloud infrastructure provided by different vendors and their market share of that and the advantages and disadvantages of the various cloud services. And we are going to see about Terraform infrastructure as a code. And we are going to see about how we are deploying the infrastructure and managing the multi-cloud infrastructure by using Terraform. Cloud computing. We all know, right, what is cloud computing? It is the delivery of computing services like server, storage, database, networking, software over the internet. So cloud computing offers a lot of advantages like faster innovation, flexible resource, and economies of scale. And here we are going to pay only for the cloud services that we are using, and it helping lower our operating cost and run our infrastructure more efficiently and scale as our business needs change. Cloud infrastructure. We have various cloud service providing by various vendors like AWS, Azure, Google, Oracle Cloud Infrastructure, Alibaba, and there is a lot of other cloud service providers are there, and each one having its own advantages and disadvantages. And this is the worldwide market share of leading cloud infrastructure service providers. And AWS is a market leader with share percentage of 32%, and Azure having 20%, and Google having 9%. And AWS, Azure, Google Cloud are the top 3 cloud infrastructure service providers right now. So I took this as the example to compare by based on various parameters. As I already mentioned, each having its unique advantages and disadvantages. Okay, suppose I am going to implement my data center and I want to utilize the advantages of the different cloud service providers. For example, if you take, I am implementing my infrastructure by using Google, AWS, and Microsoft, then the challenging part is how to manage the different cloud infrastructure. To overcome this challenge, right, we are going to use Terraform infrastructure as a code. By using Terraform, we can manage multiple cloud infrastructures. Okay, Terraform infrastructure as a code tool from HashiCorp for building, changing, and managing the infrastructure. It helps us to manage multi-cloud environment with a configuration language called the HashiCorp language. It codifies cloud APIs into declarative configuration files. It reads configuration files and provides an execution plan. We can review that plan and apply and provision it. Terraform Plugins. A provider is a plugin that Terraform uses to create and manage our resources. So basically Terraform interact with cloud platforms and other services by using APIs, and Terraform community and HashiCorp have written more than 1,000 providers to manage resources on AWS, Azure, GCP, Kubernetes, and for a lot of other vendors. And we can find all the providers in the Terraform registry. And this is the high level representation of how we are implementing the Terraform. So to deploy the infrastructure of Terraform, right, we have the methods scope, author, initialize, plan, apply. In the scope, we identify the infrastructure for our project. Then we write the configuration for our infrastructure, and the initialize, we install the plugins. Terraform needs to manage the infrastructure, and the plan, we preview the changes and what are the infrastructure we are going to implement. If everything is fine, then we will apply, make the planned changes. Manage cloud infrastructure. To manage cloud infrastructure, right, first we need to do the installation of Terraform, then we will build the infrastructure. So once we build it, if we want to do any modification in the infrastructure, we can do the change the infrastructure. And once we used it, right, suppose there is no more, we don't want those infrastructure, we can destroy that infrastructure. Okay, Terraform supports various OS, Windows, Mac, and various Linux versions. In this example, we are going to see about how to install Terraform in the CentOS. We can install yum config manage to manage our repositories, and we use some yum config manager to add the official HashiCorp Linux repository. Then we can do the Terraform installation. Now we are going to build the infrastructure. In today's example, right, we are going to see about how to provision an EC2 instance in the Amazon Web Services. As we all know, right, the EC2 instance are the virtual machines running on AWS. To build this infrastructure, we need to follow certain prerequisites. The Terraform CLI should be installed, and AWS CLI should be installed, and we should have AWS account and AWS credentials. Once we have all this, then we can configure the AWS CLI from our terminal, and we can input our AWS access key ID and secret access key. So once we did all the pre-configurations and installation, initial settings, everything right, then we are going to write the configuration. The set of files used to describe infrastructure in Terraform is known as Terraform configuration. As I already mentioned, right, today we are going to see how to deploy the AWS EC2 instance. So we are going to write our first configuration file to define a single AWS EC2 instance. And each Terraform configuration must be in its own working directory. So we are going to create a directory here. Then we are going to change into the directory. Then we can create a file to define our infrastructure. And this is the complete configuration to deploy EC2 instance with Terraform. So this basically contains 3 blocks. One is the Terraform blocks and provider block and resource block. In the Terraform block, we provide the Terraform settings and provide the provider informations, and we can get the providers from the Terraform registry. here, right, we are going to use HashiCorp AWS providers. And in the provider block, we can define the specific provider settings. In our case, it is the AWS. And in the resource block, we are define the resource settings that we are going to use. Okay, here we are defining the resource type and the resource name. By using the type of resource and the resource name, Terraform creates the unique ID. That is the unique ID it going to follow in all the configuration settings that we are going to use. And in our example, right, we are seeing here how to deploy AWS instance, EC2 instance in AWS. So in the same case, if you are going to deploy in Google or in Azure, right, simply we need to use Azure provider and the Google provider and define the settings accordingly. So once we created the configuration file, then we need to initialize the directory. So when we create a new configuration or check out an existing configuration, we need to initialize the directory with the Terraform init. So initializing a configuration directory downloads and installs the providers defined in the configuration. In our case, it is AWS provider. Now we can initialize the directory by using Terraform init command. So once we provide the command, it initializing the backend, then initializing all the required plugins, and the Terraform, we can get the message as Terraform has been successfully initialized. So once we initialize, we need to format and validate our configuration file. It always recommend that we should use consistent formatting in our configuration files. For that, Terraform format command helps us to achieve it. And also we need to make sure our configuration is syntactically valid and internally consistent by using the Terraform validate command. So by using Terraform validate, right, if we execute it, if all our configuration is valid, it will provide the success message. So once we create the infrastructure, right, we can apply it by using Terraform apply command. Once we execute it, an execution plan has been generated, and we can see what are the actions that Terraform going to do by using symbols. In this case, right, it using the plus symbol to create it. And you can see the message here, Terraform will perform the following actions. It creates AWS instance app server will be created, resource AWS instance and app server. We can see all the related informations here. And after this, it will ask us to whether it can proceed with these actions. You can always review the configuration settings, and if you are not satisfied with it, we can provide no by, then it will cancel the configurations. But here everything looks fine and we provide the proper configuration settings, so we can provide the enter a value as S. Once we provide the value as X, it's executing the plan and it will wait for a few minutes for the EC2 instance to become available. You can see all the updates from here, and once it created, right, we can get the message apply complete and one resource added. So now we created the infrastructure by using Terraform, and we can verify this EC2 instance in our EC2 console. So once we created the EC2, right, then we need to inspect the state. So when we applied our configuration, Terraform wrote data into a file called terraform.tf state. Terraform stores the IDs and properties of the resource it manages in this file. So by using this file, we can update or destroy the resources. And the Terraform state file is the only way Terraform can track and manage resources. So we need to store this file securely and restrict access only trusted team members who need to manage your infrastructure. And we can inspect the current state by using Terraform show command. This is the output of the Terraform show command, and it will provide the complete information. This is not the complete information, just this is the sample output I am providing here. Apart from that, lot of other information also is there. So by using Terraform show command, right, we can get complete information about the EC2 instance we created. Okay, we completed the infrastructure and everything we created successfully. And after that, you want to do some changes in the infrastructure. How we can do it? We already see the configuration file, right? Simply we can go and change the modification settings, whatever you want to change, right? We can modify it. And AWS provider knows that it cannot change the AMI of an instance after it has been created. So Terraform will destroy the old instance and create a new one. It is not modifying here. Whatever the infrastructure already created, it destroying it, then it creating the new infrastructure based on our configuration settings. So once we modify the settings, right, then we can apply the Terraform. So once we apply, an execution plan has been generated. And here, since we are modifying, right, it's showing the minus and plus both symbols. So first it destroying the existing infrastructure, then it creating the new infrastructure. So here you can see the message AWS instance app server must be replaced. And as usual, right, it always asks the user to confirm and provide the option to review the settings. Once we provide yes, then only it will execute and modify in the settings. You can see all the updates here, and once the apply complete, one resource is added and it destroyed the one resource. Okay, so we see here how to build the infrastructure, how to create the infrastructure and modify it. So once we completed all our infrastructure and our project got completed, or whatever the requirements, right, that it get completed and we no need the resource anymore, right, we can destroy the infrastructure by using Terraform destroy command. So once you provided the command, right, we can see the actions that Terraform doing here. So it's showing us the destroy, and Terraform will perform the following actions. So AWS instance app server will be destroyed. And it will ask us, do you really want to destroy all resources? Once we provide yes, it will start to destroy the resources, and once the destroy completed, it provides the message saying that one resource destroyed. Okay. Now we are going to see about what are the advantages of the Terraform. As I already mentioned, right, Terraform can manage infrastructure on multiple cloud platforms. And the human readable configuration language helps to write infrastructure code quickly. And Terraform state allows to track resource changes throughout our deployments. So basically, Terraform helps us to resolve the problem of managing the multiple cloud infrastructure. And we see that, right, various cloud vendors having their own infrastructure as a code, but that manages only their infrastructure. Suppose for AWS, we have the AWS cloud formation, but it manages only AWS infrastructure, but it cannot manage other vendors. So the Terraform has the advantages of managing multiple cloud infrastructure. So with this, I am completing my session. And I like to say a few words about me. I am Kanna, working as a senior test manager with 14 plus years of testing experience in data storage domain. And I am having very good experience in testing multiple storage vendor product. And currently I am working on cloud storage with AI ML projects, and I am having a very good expertise in self-storage, Kubernetes, and managing multi-cloud infrastructure by using Terraform. And also I am a Oracle Cloud certified practitioner and certified Scrum Master. And if you have any questions and if you want more information, you always contact me by using this LinkedIn profile and in this mail ID. And please provide your feedback. And also thank you for attending this session. And I like to say special thanks to Sneha for providing me this opportunity to present my session. Thank you.